Hello, 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 everybody. Thank you so much for your time today. Thank you so much for coming to listen to Ibrae. He is a student from Migot's Advanced Python class. He started with introductory Python and has graduated from Advanced Python class. Today, he's going to be telling us about the Bitcoin price prediction using data science and machine learning. So he's going to be taking nuggets and pieces of what he's learned throughout his Python journey, introductory and advanced Python, to be able to walk you through this. So without much further ado, Ibrae, please go ahead and take over and let us know. And guys, he's going to walk us through what he has learned, and then feel free to ask the questions to Ibrae or to me, God, after the presentation. Over to you, Ibrae. Thank you so much.
Okay, thank you very much. Thank you very much, Jackie. Thank you very much, God, for this. As Jackie has already said, my name is Ibrae Kosso. I am a Python Advanced Python Programming class. I've been in this class for now since November last year, where we started from introduction to Python, and eventually we proceeded to the next advanced stage. And now this is where we are winding up with the project. So this is a presentation of what we've been doing from November last year until now, finishing the advanced Python programming class. I am, as I said, my name is Ibrae. I am an intern at Kenya Revenue Authority, KRA, Moyale Station, where I'm working as an ICT support. This internship is kindly different from the normal internship, whereby this is a digital talent program. This is an annual digital talent program by the ICT Authority of Kenya, where they annually absorb like graduates every year, and they are deployed to various stations depending on your specialization and what you really want to do. So for me, I'm deployed at KRA, Moyale Station, and I'm working as an ICT support. That's introduction about myself. So today, as you can see on my screen here, I'm presenting Bitcoin price prediction using data science and machine learning. This is what we'll be discussing for the next session. Welcome all. First and foremost, I would like to acknowledge those who have been very instrumental all through this journey, and those who really did something that I can say I would like to acknowledge at the end of this. They really made the realization of this project and the effort that I really put in to make a presentation today regarding Bitcoin price prediction using machine learning and data science. First, I would really like to, in a very special way, thank God first and foremost for the strength, for the wisdom to finish this project, for the help that I had for this entire season when I'm doing introduction to Python class until advanced stage now. Secondly, I would really like to, in a special way, give my gratitude to George Migot, who has been our instructor, who has been a tutor from introduction until the last level where we are graduating from advanced Python class. He has been really instrumental in that, from actual teaching to being a tutor to working with us and everything. Secondly, to my classmates, we've been having a number of kampunjis where we are working together as a group, where we are sharing together assignments. We most of the time meet together at a time like this on a Zoom session where we interact, ask each other questions, and this has been one of the key things in my learning. Thirdly, Jackie Agieba, who has been very motivational. Jackie has been very motivational for me. I can say for the time we've been in this class, Jackie has been there to say, yes, you can do it. Yes, you can do it. I think she's a source of inspiration. She really gave me the energy that I needed. Sometimes when you feel like, you cannot do, you are so much engaged, then she's always there to give you one word that keeps you going. And in a very special way, I also acknowledge her. Going now to the main part of this project is about Bitcoin price prediction. First and foremost, what is Bitcoin? I would like to give you an overview of what Bitcoin is. Majority maybe not understand, so let's start from the scratch. What's Bitcoin first? Bitcoin today, it's a form of cryptocurrency. It's one form of cryptocurrency, and when we say cryptocurrency, cryptocurrency is a form of virtual or a digital form of medium of exchange, which is alternatively going against an aside alternative for the form of medium of exchange that we are having in our market today. So besides money, Bitcoin, it's just like money, it's a medium of exchange, but this one, it's a digital form of exchange, whereby everything is digitally owned. This platform is quite from what we are having in our today's day-to-day, that is money. Money is entirely controlled by bank, and then it's regulated by the government. So there are a kind of a third party that is involved in this. And we all know how money is being operating. And definitely for every country, there is a form of currency associated with that, with varying values. And the values for Kenyan money, dollar, and the other, it's different. So each and every country manages their own currency. In that, they are centrally owned by someone. But for Bitcoin, it's quite different. It runs entirely on an online platform. This technology is built on what we today call blockchain technology, whereby this form of cryptocurrency is decentralized in that everybody in that network have access to what is going on. You can buy Bitcoin, you can sell. The way you can buy, you send, you sell, you lend, you borrow, the same thing you can do in this platform. It's just that this thing is entirely digitalized. And for this case, we do not really need to involve any middleman or any form of government intervention or bank as is in what we are having with money. So it's entirely independent and a kind of really transparent form of money whereby you can access anytime, any form. And then this is a form of transaction whereby you can do it internationally with anybody who is anywhere across the globe. So that is an overview of what Bitcoin is. Price prediction concept is now, as much as yes, this is a digital form of currency, when we talk of digital, we always think of a way of making things easy and simpler, but for Bitcoin, it has not been the trend. Since the inception of Bitcoin and since when the Bitcoin has came into use, it has not really been picking up because first and foremost, people do not understand what it is and how it works. Secondly, people are with due to lack of knowledge and this kind of ignorance that is there, they do not really come on board to invest in this. Because the strength and the value of Bitcoin technology, Bitcoin is entirely about investors. The more people, the stronger the network. The stronger the network, the more valid this thing is. So its picking up is entirely on people coming up together, joining this network and embracing this form of exchange, which is an alternative of the money. And apparently, it has more advantages in comparison to the what we are using today, money. So the concept of price prediction now is due to low investors, due to many people not knowing what this is, due to many people not coming to invest in this, the prices of Bitcoin is one of the things that is really fluctuating, going up and down. And it is believed to be like 50% going up and down in comparison to any stock exchange in the market. So in one particular day, the price of Bitcoin can go up and down 50 times anything else. So that is a very high level of fluctuation. And this is one of the things that really scare investors to come on and join this network. So since its inception for the years that it's been there, definitely there is buying and selling that has been involved. So over these years, we are having a data that has been recorded and it's been there. So what can we do to help these people out there in a way to make a prediction of what Bitcoin prices will be in the future? I think this will give them an insight of what it will be, and then more people will may think of, yes, I can invest in this. So a price prediction, as much as it's a complex task, but using what we already have, that is Bitcoin prices data and machine learning and the technology that we are having, we can come up with the act of trying to determine what the future value of Bitcoin can be. The successful prediction of future price could yield a significant profit for investor. Thus, there is need to come up with an accurate means of predicting market trend. Now, in the next stages, what we are discussing is what these accurate means are. How accurately can you think we can make a price prediction which will be influential to the current market of Bitcoin? Secondly, my topic reads three keywords: Bitcoin, price prediction, data science, and machine learning. Bitcoin's price prediction using data science and machine learning. We've discussed what Bitcoin is. In this stage now, I'll give you an overview of what data science is. Definitely each and every one of us, we understand what data is. Data is a collection of information that has been gathered together from different sources, or be it from any source, any information about something. So definitely, since the Bitcoin has come into market, obviously there is that data that has been there. What can we do with this data? So data science is an interdisciplinary field that uses different concepts from mathematics to computer to domain to any knowledge. It uses some statistical kind of tools to able to extract information from this. And the main goal of data science today is to help in decision-making process for any organization or any client who has invested to do something on data science. So basically, data science is studying data and revealing usable insights from this particular data. And when we talk of data science, definitely there are a number of stages from data, raw data, to finally coming up with an insight from this data. And these stages are differently categorized. So you can see from my screen, first and foremost, you really need to have that data itself, data extraction, data collection, that is. And then data preprocessing, creation of modeling, optimization of modeling, deployment of model, and creating visualization reports. So this is entirely what data science revolves around. So, and as we proceed step by step, we will see how we are going to make use of Bitcoin data, past data, and finally come up with a visualization report and providing it to stakeholders, how this process can go by. First, you can see a Venn diagram here that displays a few things joined together. This is entirely what data science is. Data science is not just one thing about computer. It's not about IT. It's not in any way just entirely related to computer science or something like that, as majority of people definitely will have perceived. Data science is a field, a diverse field that requires different things. So from here, you can see on your left, there is a domain science. Domain science is conceptual knowledge about the domain whereby you want to apply the concept of data science to. Data science can be applied in the field of HR. It can be applied in business and finance. It can be applied in the health sector. Basically, what are you going to do with data in this particular sector? So domain science is the conceptual knowledge about that particular sector from where you want to work with its data. You can see there is domain expertise, there is research, statistics, algorithms, programming skills. Definitely, you need to have some concept of programming skills or IT skills, analytical system, domain space. So these entirely working together and cumulatively will give us a result whereby we can say this is data science. And this is entirely what we'll be going to do for this project. Going forward, I want to explain the concept of machine learning quite different. First, to give you, let's get you back and to the reality of what's going on in the world today. We know we are welcoming the fourth industrial revolution. This industrial revolution is associated with a number of technical, engineering, IT, and digitalization coming along with this. New technologies like Internet of Things, artificial intelligence, 5G, blockchain technology are integrated into this aspect altogether towards making an easy, a simpler lifestyle for human society. So generally, we are moving toward digitalization, whereby everything has been simplified from the traditional means. And this is entirely what this digitalization is working toward realization of fourth industrial revolution. So for our concept here, we have artificial intelligence as one of these emerging technologies that are geared towards the fourth industrial revolution. I'm sure everyone must have heard of an artificial intelligence. But in one simple word, what an artificial intelligence? What do you think an artificial intelligence means? Artificial and intelligence. So definitely, intelligence is some kind of clever or information, anything intelligent that you can do, cleverly contrived in any way that you can do. Artificial, how is it artificial? So in one simple word, I can say artificial intelligence is enabling machines to learn. When I say machines to learn, the computers that we use on our day-to-day basis, what do you think your computer knows about you? You connect to internet, join an internet, search something. There is a history that remains here. You trying to register your emails and password, there is information definitely there. Such that to a point when you go to the same browser and you type a few words, then it will suggest for you what next, depending on what you've already searched. So you see already somewhere there is some concept of memory that is kept by your computer regarding what you've been searching and giving you suggestion. Sometimes it can even give you a suggestion regarding what is being searched, the current news that's been trending. So you can see this machine is acquiring something in the background that you're not aware of. So we can say machine can learn. So that is what entirely artificial intelligence is. We are enabling now these machines to learn. there is a concept of human involvement, intervention with this computer, in a way, working with this computer to ensure that it learns, it's able to make decisions, it's able to act and rationally think like human beings, like me and you. So in the eyes of researchers, AI is one of the concepts that first, the idea of AI has been, there is a guy by name Alan Turing in 1950. He just proposed to consider the question, can a machine think? So that can be a question that is geared forward from there. And then in 1956, a guy by name John McCarthy said artificial intelligence, this is a branch of computer science that is concerned with making computers behave like humans. And ever since, this revolution has been building up and gradually growing to something that is artificial intelligence, in its simpler terms, from weak to strong AI. AI, the question is, has the AI gone to strong stage? So over the years, it's still growing, and we cannot imagine what tremendous that can be done by this AI concept. So intelligence is like what we have in our day-to-day activities can be divided into different categories. The linguistic intelligence is the verbal intelligence, ability for one to speak clearly and able to convince others using word of mouth. There are those who are good at verbal intelligence. There is mathematical intelligence. There is spatial, bodily, kinesthetic, musical, and every intelligence. So intelligence, even in our day-to-day life, human intelligence is divided into various categories. So this is a Venn diagram which is trying to express different concepts that are brought in together in artificial intelligence here. You can see there is data mining, there is databases, machine learning within AI, pattern recognition, statistics. So all these are kind of key concepts in artificial intelligence, which is in any way borrowing something from AI, or AI is working with something in that particular field. So there is a simple diagram here. Here is where I'm trying to explain now the concept of machine learning that fits in my topic using the artificial intelligence concept. Machine learning is one of the core areas of artificial intelligence. In achieving its aim of enabling computers to think and act rationally, artificial intelligence uses what we call machine learning. Machine learning is entirely enabling these computers to learn from something. There are different categories of machine learning. And then within machine learning, we also have something called deep learning. Deep learning is just a kind of an advanced stage of machine learning whereby computers are made to mimic human brain. They are made to think like how our brain works. So from 1950 inception AI, 1980, the concept of machine learning has been brought in, and in 2010, we also had what we call deep learning. So since it's one of the key areas in our project, I want to go in depth and explain what machine learning is. Machine learning, including the deep learning, that is, it's study of learning algorithms. When we say machine learn, how can machine learn? There are a number of algorithms that are brought in. For a layman, what we say an algorithm is a kind of a procedure, a step-by-step procedure that is used in solving a particular problem. So basically, algorithm is a procedure to achieving a solution to something. So when we say machine learning, it is a study of learning algorithms of different procedures. And there are a number of algorithms in machine learning. A computer program is said to learn from experience with respect to some class of task and performance measure. So when we say this machine learn, definitely human beings as we learn from each other, we learn from what we read, we learn from someone else. There is everyday learning for us. Similarly, machine also learn. But how does this machine learn? Machine learn from what we call data or experiences. Any experiences or exposure it has had, depending on how you've used, depending on the data that you've saved or what you're doing, machine will learn something from this. And how often it gets this experience or how often it interacts with this data, it's what defines its level of performance. So it's able to learn from this and able to make a prediction or say something about it at the end of it all after learning. Just the way we learn, and then after learning, we are able to convey some kind of information that reflects what you've learned. The same way, experience is what the machine learns from. And then there is task. The task is now the algorithms that is in the machine now. I said machine has different algorithms. So algorithm is the procedure. So the task that this computer does is the algorithm. And then finally, there is the basic understanding. The basic understanding is what has this machine acquired from this experience, whereby our experience for machine is in the form of now data. So a machine acquires an experience from the data, and then the task that this machine done is the learning algorithm, and then what has this machine understood is now the measure of performance. So there are different scenarios of machine learning. First and foremost, a kind of face recognition or speech recognition, or in whereby maybe in supermarket or where you go, whereby a machine is used to a kind of detect if there is any faulty item or a biometric search form of thing. These are what we call handwritten rules and equation. So face recognition, speech recognition, biometric search, I think this is one of the things. And then at a different stage categorically, you can say a fraud detection from a transaction record, maybe in bank. And then in a different category, this is now in aligning with what I'm discussing here about Bitcoin price prediction. We can use a machine to make a forecast or future predictions of something. So categorically, machine can also be used in predicting something that is to happen or making a forecast. Machine learning, for a machine to learn, there are a number of processes that goes in. First, machine learn from experience, and the experience is in the form of data, as I said earlier. So for machine to learn, first, there should be the data involved. Where are you going to get this data from? So as one of the stages, data collection is a key thing in machine learning process. After acquiring this data, how are you going to work with this data? Transition this data from a different stage to another, depending on how you want your machine to learn, on what you want your machine to learn. It's like you get a food and then you process this, you raw food and then you cook and then it becomes something else, something edible. The same applies. What are you going to do with this raw data? That is entirely about data cleansing. Next, you can see there is a feature extraction and selection. Data can be having different features. When we say this data, it comes in different form. There are data that have labels, others don't have. There are those data which have different columns, different rows, different form of description that goes into this data. So which one do you want? You extract the data that you want to work with. That's the concept of feature extraction and selection. And finally, model training is now you train your machine on that particular data, on the processed data. And then after training, definitely for every training, definitely for every class, there is an assessment. So model evaluation is you are trying to now evaluate your machine. How intelligent is my machine? I have given my machine this, and I want to see what it has acquired from that. In layman, that is. So model evaluation is all about that. And finally, after machine has learned something from what you've trained, then definitely you can deploy your machine in an environment whereby it's able to work now. This machine has learned something, it's clever, it's intelligent machine. What is it able to do? How can it work? Where does it work? Model deployment is it. When we talk of machine data, a data set in machine comes in different way. A collection of data used in machine learning task is what we say data set. So each data comes in form of a sample. So for this particular set of data that I've acquired maybe from area A or about A, this is sample this. And then you can have different samples of data depending on the sources, depending on the type of information that this data carry. So samples is nature of data, types of data, how many data. There is sample A, sample B, different thing. In machine learning, as you say, the keyword is training. We need to train our machine. We need to take our machine to a form of a class to learn. So our data set, it has to be split into different forms. You can see here a training set. This is a set of data on which you train your machine. This is a kind of information that you give it to your machine to learn from. And then there is test set. This is a kind of now a sample of a subset of the data set that you've split to set aside for your model evaluation to test if your machine has learned. So in machine learning, There is a training set and there is a test set. So for our case here, now that we've seen what data is, what machine learning is, and also a concept about Bitcoin, since Bitcoin has came into the market, definitely there's a record of this that has been kept in the internet. The internet keeps everything. So over these years, as you've had the prices of Bitcoin going up, going down, definitely there is a record of it. It's been recorded on each particular day, the highest price of Bitcoin, the lowest price of Bitcoin. So I've tried to explore the internet and see the kind of data that I will acquire about Bitcoin. At least I get to understand how the prices of this Bitcoin has been trending over the years. So a snapshot here is just to give you what the data looks like. I acquired this data from Yahoo, from that website. You can see there, Yahoo historical data of Bitcoin, where this data has been recorded over these years in form of a CSV file. And looking at our data, you can see the dates, and then you can see the open. The open is the opening price of Bitcoin on that day, and then there is the highest price of Bitcoin on that day. You remember, as you said earlier, prices of Bitcoin is one of the most volatile thing in the market compared to stock prices or anything else. Volatility in that it changes randomly over time and quickly. In a particular day, it can be ranging so fast, like 50 times compared to stock prices, maybe. So on a day, we need to register. There is a record for the opening prices, the highest prices. Low there is the lowest price of Bitcoin on that day, the closing price of Bitcoin on that day, the value, and market capitalization. So the raw data is in this format. The data that I acquired is in this format. So I'll just give you a snapshot of this data look like. It's in Excel, a CSV file in Excel. So data collection is the first stage you see. So I have collected this data from Yahoo in this format. Going forward, yes, you have the data, you've downloaded the data. What are you going to do with this data? There are different tools in IT, in computer. So where are you going to work with this data? How are you going to work with this data? What tools are you going to use? So for this particular project, there is Python programming language that I used. Python is one of the very famous programming languages, especially for data science. It's the most preferred programming language for data science due to its rich libraries, due to its capability in data science. What you can do with Python is marvelous. And then the environment that I was using there is Jupyter Notebook. That's the environment, the text editor that I was using in writing of Python scripts. That's where I uploaded my data set. That is where I worked on my data using Python, multiple Python libraries on Jupyter Notebook. So yes, I downloaded the data into my computer from the internet. So here you can see loading data to Pandas data frame. Pandas data frame, this is in Jupyter Notebook. After uploading this data, this is the snapshot of how that data looks like. So here what I did is I just converted the date to an index so that the date will be an index for my data. So this is similar to what you've seen earlier. So this is the first stage now. Next, you've seen the data. Yes, it's a huge data of around 5 years ago. So 5 years data is not small data. It's a big data. Definitely, you can go through. You can see all you can see are values and the prices, and there is nothing you can deduce from that in that format, in the format of table that you've seen. So what I did here is I visualized this data on a graphically. So you can see the prices of Bitcoin over the last 5 years from 2014 to 2020, towards the end of 2020. You can see how that graph is going up, going down, going up, going down. So when we talk of visualization, is now how you can see the trend of Bitcoin prices over these years on a graph. So one can see just from this graph, you can deduce something. You can get to acquire kind of information. There is a knowledge that you can discover from this. In that, maybe somewhere in 2018, the price of Bitcoin has gone really up. That implies that the price is so high, whereby at this point, if you have Bitcoin, it's the high time for you to sell. You can sell at a better price. So for investors and for traders, what they are looking at is the price of Bitcoin going up or down. The time that is going up, that is when many investors will be selling out. And the time that it is going down, that is the time for you who do not have Bitcoin. You can register on crypto network, you can make to buy Bitcoin prices, it's going down. That is the cheapest price. So that's the time you can flock to get to buy. So already you can deduce something from this, the best time to buy and the best time to sell. And you can see the graph has two lines, the red and blue. The blue is daily record of Bitcoin, and the red is monthly average in every month. So towards 2020 and 2021, that is where we are, you can see the prices has picked up again and it's in the climax. So that is the raw data, that's visualization of raw data. I've not done anything or removed anything from my data. I just visualized to see how the trend of Bitcoin prices over these years has been. So data processing now. Yes, we have the data, but at this stage now, you need to analyze this data. You need to explore this data. You need to extract what you want from this data. You need to feel if there is anything missing in this data. You need to process this data. It's like you need to cook and prepare this data for your project. So when we talk of preprocessing, it's like you're preparing this data. Explore, go through, analyze, and make changes depending on what you want to do. So, because it's entirely about the data. Data is the backbone of everything. If you have a good data, then definitely your machine will learn something. Machine learn, you have a good model. So a good data will definitely lead to a clever machine, that is in one word. So without data, there is no good model. There is no good machine learning model. So you can see first on the left side is data cleansing. If there is any missing value in your data, that's the time you feel you detect, eliminate any form of errors or any form of outliers. And then data dimension, you also simplify the data attributes to avoid dimension explosion. So if the data comes in a very big dimension, you take in what you want. Which dimension would you want? What is necessary for your project? That is. Data cleansing and feature extraction. This is pre-processing of lost data. I've already explained this. Processing of possible exception or errors or any abnormal values. Because in the end, you can download data and then it's too big. It's not everything in this data that you need. So depending on what you want to achieve, and for our case, our goal is to make a Bitcoin price prediction. So entirely what we need is Bitcoin prices, probably. So you extract what you want, because one of the importance of extracting what you want is you don't need to deal with entire big data, because it will definitely reduce the training time of your machine. It will also make a complex model for you. So for you to understand, if you really understand your data, you're able to know what you will take and what you will leave. So for my case here, Bitcoin data preparation. First, I was checking if there is any null values in my data. You've seen there were data that we've downloaded. So for every columns that we have, for every features in that data set, we do not have any null values. So you can see for the opening prices, the market capitalization, it's false, which means there is no any null value. Secondly, in the right side, you can see data dimension reduction. Here, initially we are having a data, our table with 6 columns. But here we are only having 4 columns. Because my goal at the end is to predict the prices of Bitcoin. So all I need to get insights from prices of Bitcoin for the time. So the opening is the opening price of Bitcoin, the high is the highest price of Bitcoin, low is the lowest price of Bitcoin, close is the closing price of the Bitcoin. So I just discarded anything else apart from this, because this is entirely what I need for this. I don't need any other information more than this. I don't need the volume, I don't need the market capitalization. So here what I did is I dropped anything, volume and market capitalization, just to remain with prices of Bitcoin over these years. Outliers are extreme values. This is, you can do it as data cleansing when you are cleaning your data. Outlier are those values which can be erroneously recorded by someone who has been generating that data, or it can actually be, yes, there is an outlier. Outlier is an extreme value that goes completely outside the range, a value that can be too high or maybe too tiny that doesn't make any sense. For instance, there we are having Bitcoin prices that goes into particular range. If you are having any value that is too high and that doesn't even defeats logic, then that could be an outlier. So you need to detect outlier. You need to see if you are in your data there is any kind of an outlier, and this is one of the things that needs to be removed from your data set. So even the best machine will definitely underperform if there are outliers. Outliers are like a wrong information in the data. So this is one of the things that you need to detect and remove from your data set. So for my data, I was trying to detect if there are any outliers in those values that I have for the 4 columns, the 4 remaining features. You can see the closing prices, the low prices, the high, and the opening. So this range within those, the maximum is 25,000. Definitely you can see the one that goes a bit high is the highest prices, and the one that is low is the lowest price. But there is no any extreme value here. We don't have any form of extremism in our data values. There is no values that goes extremely too high. It's all within the range. So for this case, we are good to go. We do not have any form of outlier in our data set. Feature expansion, it's like this is now adding an extra feature into your data, adding extra attributes. For our current data, the attributes that we are having is the prices of Bitcoin from the opening to closing, the highest and the lowest. But here now, next, the last, we have a new column. That is a new feature in this data. There is an average feature. So this is basically an average. I calculated an average of the Bitcoin price on each day. So this average is an average of Bitcoin price on an entire day from its lowest to the highest, from the opening to the closing. So I just made a mean of those 4 values, and then you have an average of it. Data preparation now. Here, now that we prepared our data, the next thing is that we want now our machine to learn from this. We are going to take our machine to like a class. Let this machine learn from this data. So first and foremost, we need to separate the attribute from the labels, whereby the attributes are the features, the label is a target. Here, first thing I did is I created a target for this data. Our target is, it's like what you want to achieve. What is your target? So price after 2 weeks is the target for this. Because it's like an input and an output. For every input, there is an output. For every features, then there is a final target. So what's the target? The target for this is price after 2 weeks. This is a label I added. This is a new column that is added to our data. So on your left, on your right side, you can see there is X train, Y test, and X test. Machine learning algorithms, it works like from our basic knowledge of mathematics, when we are drawing graph, for every X, you remember there is Y. And then the Y is dependent on X. So that is the concept of X and Y, whereby X in this case are the input and the Y is the output. So X is the features and the Y is the target. So I split my data into training and the test set, as I said earlier. Because in machine learning, you need to split your sample data into a subset, whereby your machine learns, the one that your machine learns from, and then there is another subset that you use to evaluate your machine, to your model. After learning from this training portion of data, then there is another one that is set aside to test if this machine has really learned something, to test the performance of this machine. So here we have already split our data into training and the test set, of which now the training has around 1,638 observation. That means this is like an 80% of our data set has been portioned into the training set. So the training set carries like an 80% of our data set. And then the test subset is around 410. 410 is the remaining 20%. Now, the concept here simply is we train our machine, we give our machine questions to learn from, now the training set, and then finally, we need to test this machine. Has this machine learned anything? So at this stage, we need to split our data. And that's what we did. So After learning, after splitting your data, after working everything with your data, the next stage is machine learning algorithm. Machine learning algorithm, as I said, algorithm is the procedure. So we have many machine learning algorithms. So it's at this stage now you choose which machine learning algorithm suits best your problem. We've seen our data, we've seen what goes in our data, the values that we have, the kind of data type that we are having, the level of our data, the labels that we have in our data, already you've seen that. So the next stage is we are choosing which machine learning algorithm are we going to train now. So before, this goes into a different stage. In machine learning, there is a supervised learning and there is unsupervised learning. The supervised learning is where you train your machine on a data with the labels. You have labels for this data, and then the machine learns from these labels, and then it gives you an answer after learning from this. The unsupervised learning, this is a version of machine learning whereby the machine automatically learns. You do not need, it doesn't require any form of human intervention. The machine definitely learns from huge data, which is definitely unlabeled. It doesn't have labels. And then it uses a kind of algorithms in the background, and then it categorizes this data into groups. That is what is a clusters. It clusters this data depending on the similarity. So the closely related data sets are categorized together and classified. And then the other category, depending on the similarity, is also categorized. But for the supervised learning, the machine learns from data with the labels, and then there is a target. So after learning from the label data, then it gives you something. It does something. It makes maybe prediction. It maybe makes a classification, and there is a specific target for this. So basically, the goal is to answer a specific question for supervised learning. And then for the unsupervised learning, what I've already explained. So when you say supervised learning, in our case here today, we will be entirely using a supervised learning form of machine learning. In supervised learning, we can be having a classification and we can be having a regression. Classification is whereby a problem is classified into specific categories. It doesn't have it's maybe it can be a true or false. The category, the target for this is you have to classify this data or information into categories, whereby a, a group of data can be belonging to the same category. For instance, true or false. True or false is a kind of classification task. Yes or no is a kind of a classification task. So on the other hand, regression is now the data set that has a form of task whereby you are dealing with a numerical values, a continuous values, a real values that is. You do not have any specific category, but you have a specific answer to every occurrence of the data. So for our classification problem, we are having many machine learning models. You can see logistic regression, support vector machine, neural network, decision tree, random forest, and others. Naive bias, also classifier, supervised classification. And then as well, we are having some of these models which can be used both for classification and regression depending on functionalities. So for instance, you can see the support vector machine SVM is a model that can be used both for classification and for regression. Decision tree, the same. Random forest, the same. So how it works varies. For a classification problem, this machine learning model has a capability to work with the classification task and also with the regression task. So our next stage here, we have to analyze our problem. We've seen our data, we've explored our data, we've done whatever it's needed to cleanse our data and pre-process our data. We've also gone through machine learning, how machine works, the categories of machine learning, supervised and supervised learning. So we can, at this stage now, using the data sets that you have and the objective of what you want to achieve, you have to select which kind of machine learning algorithm works for you. And for this, you have to select wisely because different machine learning models is entitled to specific kind of problem. So you have to know that's why exploring your data and understanding your data and having the domain knowledge is necessary here. So going back to our case study about the Bitcoin price prediction, the data that we have here, it has input in form of Bitcoin prices recorded over the years from the highest to the lowest opening and closing prices. And then our target is the price next week. So remember here, entirely we are dealing with prices of Bitcoin over these years. Firstly, we are having a numerical values, which is a continuous value. All of these values are independent. So for one, it's not in any way classifying prices of Bitcoin to something. It's that for these prices over these years, the target is this. So it's a specific value that goes in. It's not in any way shared or categorized. So for one, it's a kind of a regression problem. And you've seen for supervised learning here, we are dealing with a labeled data, data with labels. So in our case, our data has labels, whereby our labels is the opening, the highest, the lowest, and price next week. So there is no any form of unstructured or unlabeled data. So for one, we are not going to use unsupervised learning. Definitely this is a supervised learning, which goes in the category of regression. So combining of these features, we can provide a basis for a model to make a judgment. Now we are going to train our model, give this data to our model, and see what kind of judgment this model is going to make from this and learn from this. So our next stage is, amongst this machine learning model, which one are we going to use? So for me, exploring my data and trying a number of models depending on the accuracy and efficiency of models, I used 3 models for this particular project. First, you can see linear regression, support vector machine, which can be used both for classification and also for regression, and finally, random forest. And remember, all of these are supervised machine learning models. And in supervised machine learning model now, we already have our data. We are going to train these models on that data. And in our data, we have already separated our data set in form of targets and values. Attributes are the features. So it's like you're having input and then an output. So here, basically, we are trying to give this machine learning algorithm a kind of standard question and an answers to those questions. So you are giving this question and answer to this machine, to the model, so that it will be able to learn and acquire some kind of pattern from this, in that, in case you are given this kind of question, the answer is this. In case the prices of Bitcoin over this year is this, and then in the next 2 weeks, it will be this. So it's like you are giving a standard answers to this and question. And then after you have trained your model on that particular data, the next is you ask your model a question now. Now that you've learned from this, I want you to give me the standard answers to this question. Now you are testing your model. That is where the concept of test set comes in. You give the questions to your model, to the trained model, and then you tell him, now give me the answer. So the answer that will be given by our model is what we call prediction. Definitely, it's not the accurate exact answer, but we would want to see how close the answer given, the value is it close to the standard answer. Remember, we are having for our test training set, we are having an actual value. So you keep a portion of this data to see if this model is able to give you anything close to what you're having. So that is the whole thing about machine learning, building a machine learning model. So here, this is roughly procedures that are involved in building a model. You have to select the data, like what we did, split the data into the training sample and the testing sample. Yes, what we have. And then going to the next stage now, you are going to build your model. Now you are going to train your machine on that data using the training portion of the data. Let it learn from this. So after learning from this and acquiring some kind of pattern, comparing the target and the features, the next stage, we are going to test this model. Because we really want to understand if this model is in any way accurate. Can it give us any form of prediction which is close to the actual answers? Before we deploy this, we want to understand the accuracy of this model. So that is entirely about testing the model. After learning, definitely there is testing. Even in our day-to-day life, for everything that we learn, we have a kind of a quiz to assess ourselves. So the same way we assess ourselves, we give an answers and then we check if that answer is accurate or close to what the actual answer is. Basically, this is what machine learning, building a model is all about. The training sample of the data is to train the the model and the test sample of the data is to see or analyze how accurate or how close can your machine predict. And then finally, after testing the model accuracy and you've come to realize that it's accurate and this model can do something, yeah, you can deploy in the market. You can deploy the fully trained machine, and as you go on, you can now tune. You can tune your model in that you change some information, you add in more features, you change some parameters, you adjust this thing, fine tuning your model so that it will be more accurate. Yeah. So let's go ahead. First here, we have linear regression. As I said, we used 3 models in this case. So we have already cleansed our data. We've already worked everything on our data. Here we are trying to use a machine learning model or algorithm by name linear regression. So to explain a bit technical part of it is a linear regression is working along in form of a straight line on a graph. So we are trying to fit this data into this model and then let linear regression model learn something from this data and see what it can give us. So here you can see the accuracy of linear regression is about 86. So yeah. So I fitted this model into our data in the form of X-train and Y-train there. And then I have tested now to see if this model is accurate, how accurate if it is in form of percentage. So you can see our linear regression model accuracy on the data that we have is at 88%. So if it's at 88%, what can we do with this model? So the end goal of it is to make future prediction. Here at this stage, we are using linear regression model that we have trained on the data that we had, Bitcoin price prediction data, and see the future prediction prices that this model can give us. So here you can see a data that is converted in form of tables in our pandas data frame. There is one column which is called prediction, and then we have another column which is actual price. So at this stage, we are trying to compare the prices predicted by the linear regression model, learning from the data that we fed, the data that we trained this model on, and then it's able to give us these prices for these actual prices. Remember, we are having a test set of data whereby we put a particular portion of data to test our model. So here you can compare the prediction prices predicted by the model and the actual prices. You can compare the two and see the variance, or I mean, a bias or a kind of an error in between those values to see if it by any way it's able to come closer to the actual value. So the closer the value to the actual prices, the more accurate the model is. So here you can compare and see. So this is the prediction is what the linear regression model is able to give us to be the actual prices of Bitcoin. So the actual prices is now the actual prices of Bitcoin that we are trying to test. So you can see the first one there is 6,588 is the predicted price. The actual price is 6,646. So this comes with a variance of around less than 100. Yeah. Let's go ahead now. Yes, you've seen the prediction prices and the actual prices. So that value is in form of table, but we want to visualize it in form of graph. I think graphically it will give us a better impression of what this model is predicting. So here, I plotted a graph of the predicted prices of Bitcoin, the prediction made by linear regression model, and a dot scatter points. You can see green scatter plots there. Those are the actual prices of Bitcoin now. So plotting the actual prices against the predicted price, you can be able to, you can compare the two. You're able to compare what has the model predicted to be the price of Bitcoin on that particular day. So how close is the line that's drawn in purple to the green scatter plot is now how close has the model predicted your Bitcoin prices. So you can see and compare how this line graph has been moving. So And we can say from this, for most of these scatter actual prices, you can see our line cuts across it, which means it's something very close to the actual price, as we've already seen. So here, this is just a graphical representation of the data set, the predicted values, and the actual values as it is predicted by linear regression model. Going next, SVM. SVM is a support vector machine. This is also one kind of machine learning, supervised learning algorithm. This model can be used both for classification and for regression, unlike the other one, in that it has a more complex functionalities that is fitted both for classification and regression. It can still as well work for both linear data and non-linear data, linear separable and non-linear separable. So there is something called kernel function, so that this model has, depending on the nature of your data, you can pick which one works well for you. So for this one, we have different kind of kernel function. There is linear kernel function for linear distributed data. There is a polynomial kernel function. There is Gaussian kernel function and sigmoid kernel function. You need to specify which kernel function would you use for this. So going forward, here I have now trained the support vector machine model using the very same data that we had and see what this model can give us. What's the accuracy of this model? So training this model on the same data, I used the RBF model. RBF is a kernel function whereby it's a support vector machine model that uses different kind of kernel functions. So RBF is Gaussian kernel function, radio basis function. So here I tried to test the train and test the polynomial SVM and RBF, that is Gaussian SVM. So you can see the accuracy of polynomial SVM is around 0.2. That is basically 0. So this kind of model actually doesn't learn anything. And then the second part, the second line, you can see the RBF SVM accuracy, the accuracy of support vector machine, the Gaussian kernel, it's around 90.92. So compared to the linear regression model, the SVM model is quite a bit more accurate with around 2% increment in accuracy percentage. So now that it gives us 90% accuracy, we want to see the actual values that are predicted by this model now. Here at this stage, you can see a table, a data pandas data frame table with prediction and actual prices as well. So the prediction is, these are the prices predicted by the support vector machine model to be the actual prices of Bitcoin. So you can see these values and you can compare the two, the actual prices and the predicted prices. So what the model has predicted in line with the actual price for that particular day. So for instance, the first one is around 10,346. The value is predicted by this model. When in actual sense, the actual price is around 11,266. So considering that bias, that residue, you can tell how accurate your model is. Same applies. Here we just converted those values in form which are in table into a graphical representation so that at least we can visualize and see the trend of Bitcoin of the prices that are predicted by support vector machine model. So the green dots are the actual prices, and the line that goes through it is the how the SVM predicts the prices of Bitcoin over this period of time. So these are the just first 30 values that are predicted here, but you can compare the closeness of the edge of a line with the green. So for the first green, you can see what the model is predicting, how close. So visually, you can see how the prices of Bitcoin is going up. Where the green dot is higher, definitely you can see the line is also going up. So that is how the trend of these prices is going up and down. So our model is able to adjust the prices of Bitcoin going up and down, and it's giving us a solution which is in a similar way going up and going down at different times. So definitely this is a model that could have learned something. If it can categorize and give us something that goes into be high price and then low price, because definitely that is how the Bitcoin prices has been. So it is able to acquire a knowledge from data that we fed. So this machine is able to learn something. So you can infer and see and make an insight, reveal something, information from this definitely. So this is a visualization of that. And then thirdly, there is an ensemble learning. Ensemble learning here, it's a kind of a machine learning algorithm whereby we will be training many basic layers, multiple basic layers, and then we summarize the results of these different learners to come up with one composite learner which contains an average answer that has been provided by different learners. So in this case, in ensemble learning, we will be training multiple machine learning models, and then we will acquire the answers that are given by different models, and then we come up with one average answer. So it's like when you're asking a question to a group of people, and then the answers given separately by each and every person is summarized. So the answers that are given by the group is summarized, and then you come up with one average answer. So this is making use of the knowledge of the mass. So the wisdom of the masses. Definitely different people working together, giving answers will give you better than one expert person that you might expect. So the concept that the machine is using here is it's training now different models, and then these are all working together on the same data. Right? So you train different model, and then you come up with a summarized answer that are given by different models and get to one solution. So it's like an averaging answers provided by different machine learning models. So one example of ensemble method is random forest. Random forest, it works using a concept of decision trees. I don't want to explain technically the decision trees, but it's a kind of whereby you train different models, different decision trees, and then the answers that you get, you merge them together to come up with one accurate answer. So it basically uses it's an example of an ensemble form of machine learning, ensemble method paradigm. So using the very same data that we've worked on, that we've used for linear regression and SVM, I trained random forest model on the same data, and I also tested how accurate this model can be. And what we've acquired, we've got from the accuracy level that this model has for this particular data set is at 91.89%. I think this is the most accurate of all. So here, the same way, I'm trying to compare the predicted prices, the prediction made by the random forest model versus the actual values of the Bitcoin prices. So here we are just having a table of the prices, comparing the actual prices and the predicted prices by random forest. So you can see here, you can compare the same way we've seen with the others. But for this one, with 91.98 accuracy, definitely it's telling us that this is giving us a predicted price which are quite close to the actual prices, actual values than the other one. So it's like more accurate. So the same thing here. This is a graphical representation of the predicted values vis-a-vis against the actual values. So you can see the green dots are the actual values of Bitcoin on that specific days, and then the blue line is the prediction values made by random forest model. Now that we've trained three models, we've tested the accuracy of these three machine learning models, and we've seen what these models can learn and predict to be the Bitcoin prices. The end goal of machine learning is to come up with a model that will make a future prediction of Bitcoin prices. That is the aim and that is the goal. So here, we want to use this model now, one of the most accurate model amongst the three, to make a future prediction of Bitcoin prices for the next 30 days. So you can see here, I used the trained random forest model to make the future prediction. And in our data set, there is a new column that I name predictions. These are the predictions for the next 30 days. So you cannot have an average for this. The model has already been trained. We want to make a future prediction for this now. and it's giving us an accuracy of 91%. So we can say this model is accurate. We can deploy this model. So this is the concept of now deploying the model in the market to make future predictions, the most accurate model. So you can see the future prediction of Bitcoin prices for the next 30 days made by Bitcoin random forest model. So here is a view of what these prediction prices are. Here now graphical representation is now I am converging the two from the dates that we have, the prices that we have for our data set. The green line there is the Bitcoin closing prices for the next 5 years from our data set. We've trained our model on this data, and after training our model and our model is able to learn and testing the accuracy of this model, we want to make future predictions of Bitcoin prices in the next 30 days, which is not recorded in any of the data set. So the yellow line here, there you can see is the future prediction prices of Bitcoin that we've seen back here. Just join this on a graph, and then you can, so that you can see how the prices of Bitcoin will be trending in the next 30 days in the future. So basically, this is the end goal of machine learning. We are using this machine learning model to make future prediction for Bitcoin prices. And I joined the two such that you can compare and see what the future predictions be like in comparison with the 5 years data that we've had. So the green line is the closing prices for the last 5 years, up until somewhere there where it's joined with yellow line. So merging these together, it's like we are coming up with a kind of trend from the last 5 years, and then we've included future prediction to this. So because at the end, we want to give insights to organizations, to investors, to traders outside there, what Bitcoin prices will be like in the future. So this is that. You've trained your model, you've did some concept of data mining and data science, machine learning, and deploying a model now. Like what we've done there now, we use random forest to make future predictions. What is a good model? What does a good model look like? What features do you need to extract to say about a model for it to be considered a good model? First, the end goal of machine learning is to make future prediction. Predictive model is to make future prediction of Bitcoin. So we've trained our data, our model on a sample of data that we've downloaded from the Yahoo for this case. So then the generalization capability is, in short, is this model able to work on a different sample of data and give you accurate results? Is it generalizable? So the generalization capability is the ability of this model to work on a different sample of data and give you an averagely accurate results. So can your model be deployed on in a different market with different samples of data and still work well? So the generalization capability is one of the factors you need to consider. Interpretability is the values that are given, that are predicted by your model. How interpretable is it? Can it be easily interpreted and understood? Is it in any form of normalized or in the interpreted version, or it just gives you the accurate values that can be read by anybody and analyzed? Thirdly, you can see the prediction speed. How fast can your model make predictions? And then you can say practicability of the model. Can this model be deployed in the market and practically works? Is it feasible? Can it be able to make to work what it is to achieve what is needed of it in the current market today? Is it practicable? So practicability concept is all about the prediction rate. Is it still acceptable in the service? Can it cope up with the current market or the state of what Bitcoin prices is being in the current market? So the practicability concept is also one of the things you need to consider to tell if your model is a good model. Model capability, that is what I've already explained. When you are deploying this model in the market, there are a number of things that can be said that can to be comments can come along. So one of the things is that there is an error. Definitely, when we are talking of prediction, this model doesn't give us an accurate exact prices. It gives us a price which can be close to the actual prices. So the error is one of the things that is associated with predictive model. And then generalization error is the error that you get when you use your model on a different sample of data set other than the one that trained on. The training error is the error between the predicted value and the actual value, like what we've had for our three models. Underfitting. Underfitting is this model able to fit different data well. So when you train your model on a sample of data with less features and you are deploying this model to use it on a different data sample with more features, definitely your model is underfitting. Your model is not able to work well with this data. It's not too clever for the data that you are feeding. It's like you are giving it more tasks than it is capable. And then there is a concept of overfitting. This is a complex model. You train a complex model on a complex data, and then you are deploying it in a place whereby you are trying to use this model on a data with few features, less than the features that this model has been trained on. So definitely this model is overfitting. Overfitting is all about the model is too smart for the task. So graphically, here I am trying to represent what underfitting is and what overfitting is. In between, we have a good fitting. So you can see a straight line for a kind of data samples which doesn't need a straight line. That line needs to be away curved. So when you sync, the blue line represents the model and then the yellow dots represent the data samples. So in the first case, it's not all the features of this data has been captured, has been learned by the model. That is where the concept of underfitting comes in. And then on the right-hand side, we have overfitted model. So here, this model is trained on too many features. And then finally, here we are having less features than the one it's trained on. So definitely this model is overfitted. So for you to come up with an effective model, you have to adjust your hyperparameters, you have to adjust your model features, and then you have to come up with a model which is good fitted for the particular task that you want it to be applied on. Yes. Thank you very much. That is what you've done for this. And yeah, I can welcome any question. If there is any question you have regarding Bitcoin price prediction, machine learning, or data science, this is the time. Thank you for your attention. Thank you for being here. And it's time to ask if there is any question.
Thank you very much, Ibrae.
Sorry, go ahead, Migat.
Go ahead, Jackie.
Ibrae, that was absolutely amazing, absolutely great presentation. I have some questions or some comments in the chat that I'd like to read to you. I know that earlier, Silas had asked, how current is your information?
How
current is your information?
This information is basically from the data that we have over the past years. When I say training, making future prices of Bitcoin, we are using the past data of Bitcoin over the years that's been in inception. So I acquired this data from Yahoo, from a website whereby the Bitcoin prices has been recorded. I downloaded this information, and then the machine learning is what is already, it's a concept of data science. So in technically, I don't want to go much to explain much about the technicalities of this. Is a machine learning model. There is a library in Python that has the capability, the function capability, whereby you are able to fit a particular data to this, and it's able to give you a prediction depending on how this function closely work with the values that you have. So this is a sample of what you can do. What I'm trying to give is that having the Bitcoin prices today, having a warehouse of data about Bitcoin, we can use that data to reveal usable insight using machine learning. Machine can learn something from data and give you a prediction to something from the data, the past data. So this is entirely about giving a concept that a machine can learn something and it can help us in making a future prediction. Yeah, so the validity of this is that we've used the data that's already in existence, and I've used a machine learning model that are already there, like SVM, linear. These are already well-known machine learning models, and then I'm trying to use this concept, merge them together, and see what we can do maybe in Bitcoin prices today. How we can win investors. So someone may think and acquire something from there. In that, with the data that we are having about Bitcoin and the concept of computer science and machine learning, yes, we can come up with something that makes future prediction of prices. So the model, the more accurate the model depends entirely on the data.
Perfect.
Yeah.
Thank you. The question was by Silas, and I see that he corresponded with Team on it. So I just want to ask them personally, Silas and Team, do you guys feel that Ibrae has answered your question to your satisfaction, or do you have further questions? If you have further questions, would you like to speak?
Yeah, I mean, so hey, Jackie.
Hi, how are you?
Good. So the reason why I'm asking is, I think, correct me if I'm wrong, the price of Bitcoin kind of almost tripled. So you went up to almost 60,000. And I'm guessing I think your last data point was below 25,000.
Yeah.
So what I was trying to get into was how accurate would that prediction be? Like, for example, we take the model right now, and I want to predict what the price of Bitcoin will be tomorrow.
Yeah. So thank you for that. That is a sample data that I've used. So that is not the actual prices of Bitcoin at the moment. I'm not giving you the prices of Bitcoin as it is yesterday or it can be tomorrow. But based on the data that I have acquired from a different website, yeah, depending on different website or site that you can pull your data from, you will be getting different values. So my concept is here is how capable can machine make a prediction of prices. So I'm not in any way giving you a kind of actual data about what Bitcoin price is now. I'm giving you an overview of what we can do with record of Bitcoin prices to give us a future prediction using machine learning. So it's not in any way replicating the current prices of Bitcoins at the moment. So depending on website where you are going to download your data from, you will definitely have different values which are recorded by different people to be the Bitcoin prices over these past years. So this is not in any way giving you an information about current prices of Bitcoin.
Silas, does that answer your question in its entirety?
It does. So it's more of you're just using sample data kind of to explain
exactly.
Right.
Yeah, exactly. So with this model, you can download the actual, maybe the more accurate data. Where you feel there is a more accurate data, you can still go and you can download that data and then you can make future prediction. So what I'm trying to say is capability of machines and the capability of data science field to make what it can do with what you have. So prices predicted by the machine will entirely depend on the data that you fed. So where I downloaded that data is now the concept. Where can you get your data from? You see,
Okay.
I'm not giving a values for Bitcoin prices. I'm using the record that is already there. So different sources will give you different values.
I'm guessing you can answer my question. So I mean, do you have a little bit? Your data is a little bit. It was a sample data, so it's not like the accurate data. So you pretty much answer my question. So so my question was different from Teams. So I'm guessing Team can speak about his question.
Team, would you like to say something? Team, are you still on? Would you like to say something? Would you like to add to it or ask your own question?
Yeah, I heard this. My question was on the linear regression part. I wanted to know how he got the 88% accuracy.
The accuracy here, the linear regression model, yes? I'm trying to explain. I've not gone much deeper into the technicalities of how these things work. Linear regression is an already existing model in machine learning. So in Python, we have a library called sklearn. So in Python library, all these different machine learning models are already defined in form of classes. So from a particular library, you can import a library whereby how linear regression work has already been programmed. So linear regression definitely works. It's a kind of a linear function whereby you are in linear regression, you're having a straight line of x against y. So against this straight line, we are trying to fit this data set into already a framework that has already been predefined in Python library. So here, what we do is we fit our data on the already existing function in Python so that we are able to, so that you can see what it can give us. So about the linear regression, what from our side, from a programmer or a developer, what they do is they call the function and then you fit that data. It's like on a calculator, you give 2 and then you multiply by 2. The computer does what it does, 2 multiplied by 2, the calculator, and then it gives you a 4. So how it drives to 4, it's been pre-programmed at the background. So this is what the model does in the background, or the computer does to give you that answer.
Thank you, Ibrae. That's a great answer. Tim, do you feel he's answered you, or would you do you want to go deeper into that?
I'd like maybe if you had shared the screen back to the
Tim, you're not very clear. Do you mind starting from the?
He has an echo.
Right. Tim, do you mind saying it again? We can't hear you very clearly.
Yeah, so I tried to answer him on the chat because I mean the accuracy is a statistical measure. So
yes.
So the way Ibrae described it is you're taking the predicted value, plus you are comparing that to the actual value and trying to see how close. I mean how well do they fit to each other. So you're taking maybe the predicted usually an x value, plus the actual, which is a y, and you're seeing if they fit on the line. So in this case, you're saying 88% of the time, those values would be on the line.
No, let me explain this. In our data set, the data that we've downloaded about Bitcoin prices, it's in the form of the training test, and then we have a test, training set and test set. The training set is the portion of data we will train our model on. So it's like you are giving the attributes and the features, whereby the attribute is the X, the independent, the prices of the Bitcoin. And then the target is the answer. So training your model on this set, you have a subset of your data set, that is the test data. You put like a portion of this data aside to test your model. Now, after training this model on that particular data, you are asking your model a linear regression. I have given you this, I've given you this question and these answers, and then you're able to learn from this answer. So now that you've acquired some knowledge from this, tell me the answers to this now. When you are using now, the concept of using the X portion of your data is you are trying to see what answer can your model give you for that particular data. You are now giving the X test, and then you will asking your model, give me the Y. You see? So you are giving this model a question and answer first, question and answer, question and answer. And then finally, after it is able to learn and or acquire some pattern from these questions and answer, that is now the training part. When we come to the testing part now, we are not giving this model an answer. We are just giving it a question. So we give it a question and then we tell this model, give us the answer to this. So the answer that this model will give us, we now compare this answer, the one that model has given us and the one that we've put aside. Remember, there is a portion of data that we've kept aside, the test set. And for this test set, we have the question and we have the answer. But at this point, we are not giving this model the answer. We're just giving it the question, and we keep the answer to ourselves. Now, when it gives us the answers, now the predicted answers, we compare now that answers with the actual prices that we've kept aside. So there is a portion of the data set that is entirely kept aside for testing the model. So at the training stage, in a simple word, you are giving your model a form of questions and then a standard answer, both question and answer. So the model is able to learn from this. It will acquire some pattern. For this question, the answer is this. So the X and Y now is there. You see, the questions will be X and the answers will be Y. So after learning from this portion of data, the training set, which comes in both question and answer, then at some point now we will evaluate our model. At the stage of evaluating your model, you don't give it both question and answer. You give it question and then you ask your model, give me the answer. So the model will give you the answer in form of predicted values. You see? So you compare the predicted values with the actual values now from the test set of data. This set of data is entirely kept aside for analyzing this model. I don't know if I have tried to answer your question in the most understandable way.
Do you team and I don't know if team can hear us. Do you team and Silas feel that he's answered the question that the way you wanted? And most I would say team if team, can you hear us?
Yeah, I can hear you.
Do you feel he's answered your question?
Yeah, he has answered the question. Maybe if I could request if you would, is it possible whether would it be okay if you would go back to the part where you had the linear, you share your screen to show the part where you had the linear, the LR?
Yeah.
Then a question to Silas.
Yes.
Yeah.
The correlation coefficient that you're talking about, is it 0.2? Okay, let me. I'll maybe when he shares the screen to the first where you have number one, yeah.
Wait, why is it 0.2? No, no, that's not it. That's not it. That's part of the formula. That's what, like he's saying.
0.2 is I am trying to convert my answers into 2 decimal places. That's why I'm having 88.14.
That's the formatting for the decimal place.
Yeah.
88.14, since you need it in 2 decimal places. So they use the format, F for format.
Yeah, I was just remembering that I'd seen something like 0.2 and I thought maybe
No, I was trying to explain like the back side of like the linear regression. Sorry for the confusion.
Okay.
I mean, I'm glad that you all have talked and clarified it, so everyone is clear at this point, right?
Yeah, it's clear now.
Perfect. Does anybody have any further questions? As I'm looking at the chat, I'm going to let you answer this question. Odongo says, same here, please. I'd love a copy of the presentation if that's allowed. When the price of Bitcoin goes up, does it go up globally or is it high in one location and low in another? Ibrae, I'm going to let you guys answer Odongo on that one as I get. And also, requesting for a copy of the presentation as well, but kindly please answer Odongo and White.
The prices of Bitcoin, if it goes up, the value goes up globally. Because for one, I've already said this is a decentralized form of system, whereby there is no government or there is no kind of bank that is involved. There is no intervention involved. So internationally, you can do your transaction with someone who is in America, with someone who is in Asia, in Europe. For as long as this person is in your network, you can use your Bitcoin value to make any form of exchange. So one of the advantage of using this medium of exchange is, first, there is no government intervention. So there is no Kenya, like when we're having the Kenya revenue for the Kenya value, and then there's dollar, and then there's euro, that doesn't involve. It makes everybody equal. And then everything is regulated by the market. So there is no middleman intervention. So I think if it goes up, it goes up. Okay.
Ibrae guys say, great presentation. Monica says that. John says that. Pretty much everybody on the chat says great presentation. I'm saying that as well. And I'm not seeing any further questions. Nancy Washira says impressive. Ibrae Odongo said that was incredible. I mean, everyone, Motion Arts just loves your presentation, and then he's telling Odongo where you got your information from. Me got stated the data set from several places, Yahoo, Google, Kaggle Data, World, and so many other sources, depending on the type of data you're in need of. So this is just pretty much, Nancy states, very elaborative. So at the end of the day, everyone is just singing your praises, Ibrae. You did absolutely amazing. And I want to open it to anybody else who did not use the chat functionality to type anything. Do you want to ask Ibrae anything, or do you want to ask Migot anything now that you have them here and you can get those questions answered?
Sorry.
Okay.
Quick question for Migot and Ibrae. So what if did you guys like try to cluster the data? I know you guys you wanted to go like the train model. Like, did you have, because it would be interesting to cluster the data, because it's more of like looking at the graph, it looked like it's like the prices, it's more like they go up and down, it's more cyclical. It would have been interesting to see if you clustered it to like some of those groups of like when it spikes and try to see when the next class is going to happen or something like that.
No, we do not. I don't think if we need to do any form of clustering, because here basically we are giving you a specific value for a specific day. So the prices as it goes up and down, for a specific day there is a specific price, and then for the next day there is also another price. So I don't think if there is any form of clustering, because this is an actual value of Bitcoin prices. So I don't think if there is any kind of clustering will help us, but depending on what you want to do, you can work on it and see how this outcome is. But for this particular project, this is what I found it will be more appealing for the kind of data that we are having and the insights that I want to put across. Yeah.
Awesome.
So literally remember, when you have this data, it's up to you. Depending on the tools that you have, you can work on it whichever you want. So using the concept of a Python programming language, IT, and different domain knowledge. If, for instance, someone from HR accounting, definitely this person will understand everything about recruiting and employing more better than us, and he can visualize or he can display this information in different ways. So how you want your information to be displayed depends entirely on you. But you try to get the best out of what you have.
What you got, yeah, that's true.
Yeah.
Great answer. Silas, do you feel answered?
Always.
Perfect. Perfect. So Migot, I'm gonna hand over to you and Ibrae for your closing statements, your closing comments, or anything that you want to add.
Thank you very much, Jackie, for doing another wonderful job. And I do also thank everybody for coming and tuning in and be patient with us. And I know it was long, but Ibrae did a good job. And I would say probably this Google material right there. So whatever happens, this thing is being recorded, and we'll be able to put it somewhere whereby everybody can access and be able to listen. And by all means, if you have any question, Ibrae, you probably will be able to share your LinkedIn and GitHub information just in case, so we can get back.
Yeah, sure.
Yes, sir. And thank you, everyone. I'm going to go ahead and turn it back to you, Jackie.
Thank you, Migot. Ibrae, do you have a closing comments or anything that you'd like to say prior to me closing the meeting?
Okay, thank you very much. First and foremost, I say thank you for everyone who has tuned in and who has been here for this long going meeting, who is able to follow the questions that you are asking. It's really moving. I really got to explain maybe what I have jumped at some point that I have not explained better. At least I'm able to tell you. And at some point, what I'm trying to give you is entirely the outputs, and I have not gone much deep into technicalities of how I have managed to do that in the background. But if there is anybody who might be interested in this field, or if there is anybody who would want to reach out to me in the field of data science or maybe Bitcoin or machine learning entirely, if there is anything that you'd want me to collaborate with you on, or if there is any kind of guidance that you'd want me to help you in, then definitely I'll be glad to work with someone in this. This is what I really love doing. I really enjoyed to be part of this project entirely. And yes, I'll be glad to work with someone in this, and helping someone else will be also my joy at the end of it all. So I'll be feeling more fulfilled if we'll be having somebody else to work with this or helping someone to acquire knowledge from this. So anybody who would want to collaborate with me on anything that I have mentioned, from data science to machine learning to Bitcoin, any field that you'd want, I'll be glad. Yeah, thank you very much.
Thank you.
Thank you, Ibrae.
Thank you. I mean, Jackie, I gotta say this though. That last statement from Ibrae has a lot of assurance. So that means this guy really got this thing mastered. That's a good thing.
Definitely.
Yeah, thank you very much.
Good job to you too, sir.
Oh, thank you, sir. Thank you.
Thank you, Migat. Thank you, Ibrae. I mean, it's so nice to see your confidence after taking Migat's introductory and advanced Python class, and to see your confidence levels at this, at this place, and also just your passion for what it is that you learned and the ability then to want to give back to the world. So I cannot wait to sing your praises, see your career trajectory, and celebrate your wins. And Migat, thank you so much for giving to the world what it is that you do, because this again is also generational wealth that we are creating and building based on the fact that you took the time to take in the students and to actually train them. It's good for you, and it's good for Ibrae, and it's good for the people then around you. So thank you. As a community, we want to say thank you to both of you guys.
Thank you. Thank you.
Thank you.
Ibrae,
and with that, I'll say, guys.
Yeah, Ibrae, you probably want to share your email and your GitHub.
Right. I'll probably share with you.
Yes, some people will need that to get hold of you.
You want to drop it in the chat?
Yeah, you're gonna be very busy, my brother.
And guys, if you don't get the contact information now, you can always reach out to myself or Migat. If you don't know Ibrae personally, we have his information. So don't, just because you didn't catch it on the chat doesn't mean that you cannot catch it right if you want to. He's here and he's,
yes,
available.
That's correct. Okay.
Mm-hmm. And Migat is available for training purposes if you're looking for introductory Python, advanced Python, or specific segments of it. He's very available to train you and a wonderful trainer. Just between November 2020 and now, he's trained over 1,000 students, so we are seeing the people who have done advanced Python and presentations. We have more presentations coming. So feel free to reach out to Migat as well for your training purposes.
So Migo, when is your next class starting? We might have like a few Kenyans who are interested.
Oh yeah, okay. Actually, I was not gonna do it, but this time I'm gonna do it in the honor of Salome too. So I said Salome, I'm gonna name it after you. So so maybe another 1 month or two, we're gonna do another free Python class, probably for 50.
So you start the intro and then go to the advanced, right?
Yes, I normally would like to go that way, so that I walk them through the process.
Okay. Because I mean, there's a couple kids back home that are my sponsor.
Okay, all right. Yeah. That would be nice, because I mean, like you see, Ibrae came in and fresh. Now you see what it's doing. I'm even scared of my job now. This guy's gonna take it over.
And Ibrae is from Moyale, Kenya. He's not even playing with people. I mean, from Moyale, and look what he's giving us.
Yeah, look at Moyale. I mean, Moyale to me was not anywhere in my vocabulary until I met Ibrae.
Ibrae, right. Ibrae, you're rapping right.
Yeah, Ibrae, I need to talk to you about you need to get started so you can get more students out there in Moyale. Spread the word, the gospel.
Well, guys, I'll say thank you.
Thank you, Jackie.
Yeah, I wanted to say
as always, Jackie, we say in where I come from, we say your heart is as clean as that of a chair.
Of a chair?
Yeah. I'm gonna let somebody tell you in the law.
Oh, okay.
Yeah,
thank
really
you.
Nice. Thank you. All right. I guess if we don't have any other questions, we are going to go ahead and wind it down. And thank you very much, everybody who made it. And even those people who could not make it, we know it's a busy time. So this thing is being recorded. Don't feel bad, still reach out. And we really appreciate you, each and every one of you. Thank you very much.
Thank you, Migat.
Thank you.
Take care, guys.
All right. Bye.
Bye.
Bye bye.
Bye-bye.
Bye.